Hello, in today's video we are going to be doing something a little bit different. We're actually going to look at something in Blender. So we've made a couple different Blender videos and people in the comments are always telling us to use Blender instead. And the thing is, we do actually use Blender, we just don't really use it for modeling. I like to use it for simulation quite a lot. Recently we've been working on an animation for like a hot chocolate company, and part of that animation was that we needed to actually have the hot chocolate come down into the cup, but then we also wanted to put whipped cream on top. I thought that what we'd do is actually make a tutorial on how to make a whipped cream simulation in Blender, because I've seen a few finished results of it, but not really any good tutorials, and I ended up having to figure out how to do this myself, and it took a fair while, so I thought, why not actually make a tutorial on how to do it? So I'll just go ahead and show you what I've made, and play this here. So it's slowing down quite a lot in the viewport because of the divisions. I've gone ahead and baked this simulation, so it is running a bit faster than it would have. But this is what we ended up making. It's not 100% perfect, but it's getting there, right? Like, it looks like whipped cream or like soft serve kind of ice cream, and it kind of falls quite nicely and combines together, and it doesn't dissipate too quickly. So yeah, I'm going to go ahead and show you how we can make this from start to finish. First things first, you are going to need a proxy cup, kind of like this. This is literally just a cylinder. If I go into the modeling view, it's just a cylinder with an extruded face at the bottom here with a bit of thickness just for something to sit on. This is the shape of our cup, and then this part here is kind of where the fluid will end, or the fluid like kind of starts in the cup. And then we have a shape here as well, to actually extrude the cream from. So a lot of tutorials you'll probably see, they'll go ahead and add in like a UV sphere and then they'll run the simulation off of that, but we are actually going to be using a star shape like this, because if you've ever looked at whipped cream when it comes out of like an icing bag or like a spray can, it kind of has this sort of like star shape to it, right? Like, it looks like this. It has these sort of ridges just because of the shape of the nozzle. I'm not sure why they make it look like that, but that's generally kind of how it looks. So we're going to be creating a shape like that instead, and then using that. And then also we'll be animating this. As you can see here, it goes along a curve, because we could just have it sitting like directly down on top, but you know, then you don't get that nice like whipped cream swirl look like this. Okay. And we also have it decreasing in scale a little bit and tapering off. So let's go ahead and show you how we make something like this. I'm going to go ahead and import the models that I have already made. Okay, so I have our cup proxy and our nozzle shape. So the thing to remember with these is that so I've actually gone and modeled my cup, okay, and what you want to make for any time you're doing a simulation, since this will be our collider, as in the actual simulation will be colliding with this object, so it doesn't just go through it like it's not there. You want this to be a bit simpler, right? So it needs to conform to the shape of your final cup model, but it doesn't need anywhere near, you know, as much divisions or detail to it. Like my cup model has this crease going down the side, and it looks a bit more realistic than this. But the actual proxy, it just conforms to it, and also the cup isn't fully extruded down, right? We just have this surface here, which will be where the liquid goes, and then the nozzle shape as well. It looks like it's going to be a little bit small, so I'll probably just go ahead and scale that up. You want it to be maybe something kind of like this, just to correct the scale. I mean, you can have it any size that you like, but I want a pretty big simulation to come out of here. And then the first thing I'm going to do as well is also bring this up to the level that we need it to be. Okay, so this, wherever this ends, or wherever this is in space, is where we're going to be emitting from, and this is the height it will fall from. So to begin with, I'll probably have it maybe down about like this, assuming we're going to kind of spiral around and up to get that nice shape. Okay, I'm just going to go ahead and rename these as well. So I'm going to call this outflow, and I'm going to call this the collider. Okay, there's one other thing we need to create, which is a cube, and the reason for that is that we need a space for our simulation to take place in. So this is essentially, if you like, it's going to be the bounding box for the simulation. And you don't want this to be too big, because then it can add complications and make your simulation take far too long to actually process and compute. So we just want to make it to be roughly the right size, or roughly the size of the area we need things to happen. So I'm going to scale it to just outside of the boundaries of our cup, this way. and then also in X. Okay, we'll turn on wireframe mode just so we can see that a little bit better. Okay, and then I'll just scale that up in Z as well to give us the height that we need. Okay, and then I'll pull that up to around about here. Okay, just make sure that's sitting just below the bottom of where you want your simulation to end, and then make sure you have enough headroom as well up here so you can go as high as you need to, and you can always adjust it later. I'm going to rename this cube to domain. Okay, we'll go back onto shaded mode, and then I'm going to press Control A. I'm going to press A, sorry, on the keyboard to select everything. Then I'm going to press Control A, and what this will then allow us to do is reset all the transforms. Now, this is important so that everything comes out of the right place. If you don't do this, things might break. So we're just going to press Control A and then reset all transforms. Something I like to do after this, because we're actually going to need to animate our outflow object here, is actually set the pivot point to it. So that when we come to animate it, it's just a bit easier. So if you right click on it, go to set origin, and then go origin to geometry, that's then just going to move the pivot point or the origin point to this. But our transforms are all still frozen, so it should be okay. Okay, next thing we're going to do is we're going to come over to this tab here called physics. Okay, we're going to select our outflow object. We're going to press on fluid. We're then going to change the type to flow. We're going to change the flow type to liquid because it's going to be a liquid, right? And then flow behavior, we're going to change from geometry to inflow, sorry, not outflow. Let's quickly rename that. Okay, then next we're going to select our domain. We're going to do the exact same thing. We're going to press fluid. We're going to change type to domain this time, and domain type from gas to liquid. Next, we're going to select our collider. Again, we're going to select fluid. The type this time will be effector, okay? So effector type collision, and then you want to make sure you tick is planar here as well for this to work correctly. Okay, so if we come over to our inflow object, if I play this now, we should get some fluid coming out of it. Okay, as you can see, we've got our liquid coming out, and it will gradually fill up the domain area. But right now, it's looking a lot more like water, right? Something like that, or like single or double cream, just very, very like non-viscous liquid. So there's a few things we need to tweak here. One thing I am going to do as well is I'm actually going to change the frame, the amount of frames we have, the duration of the timeline, just because 250 is probably not going to be enough. So I think we just go ahead and extend that, and if you just drag this out here at the bottom, this little widget here, we can see all the way to the end. Okay, so first things first, in order to change this, we're going to select our domain, and in the domain is where we have all our settings for adjusting the properties of our liquid. The thing that we want to turn on is, if you scroll down underneath diffusion over here, there's a box called High Viscosity Solver. If you turn that on, that's now going to add a lot of viscosity to our object. If we press this arrow here, we can also adjust the strength. So by default, it's only at 0.05. We're going to adjust that because I found that's not quite right for what we need. But if I go ahead and play this now, you can see it has quite a lot more viscosity to it. It's kind of like honey or like syrup. Very, very thick liquid now. And it's taking a lot, much longer time to spread out. But we'll get to that in a minute. So first things first, we're going to add our animation. So to begin with, what I like to do is turn on auto keyframe. That's just this button down here so that we don't have to set the key every time. So we'll put that on. We'll set our button here. We'll set our timeline to 1, the first keyframe. And then I'm just going to move this ever so slightly. It doesn't actually move, but just to set our first keyframe, our starting point, okay? Now we want this to happen quite quick, right? Because if you imagine you're doing spray cream, it comes out pretty fast. Doesn't take that long. So we're going to do something like maybe 20 frames per movement here. So we'll start, in fact, how about we'll start back here over at the side. Okay, and then something that can be quite good to do is just to do this from the top. So I'm going to hold down Alt and middle mouse click just to snap that view to the top there. And we'll go into wireframe mode just so we can see what we're doing. So this is where we'll start at the side, okay? And we're going to kind of spiral in towards the middle. So starting on frame 1, we'll start from the outside. We'll go to frame 20. Okay, then we'll bring it over here. just inside the rim of our cup there. Okay, then we'll come to frame 40, and we'll bring it over here. Then to frame 60, over here. And then we'll come to frame 80, go a little bit further in this time. And again, we're just repeating the process, but coming in towards the middle. Then to 120. Over to here. Then to 140. Over to here. And then from 160, we'll come into the middle. Roughly in the middle, somewhere like that. Okay? So, if we go ahead and play that now, you can see what's happening is, it's going around in a circle around the cup, okay? And we're getting our spiral shape, but you see it's kind of just making a donut blob on the ground, and it doesn't look like whipped cream at all. It looks more like something else that I won't mention, right? Anyway, we're not getting any upwards movement, which is what we want, okay? So by default, if I come to the transforms, you can see we're not actually moving anywhere in Y, or in Z, sorry. So what I'll do is I'll have it gradually change. So we'll set our keyframe for Z here. Okay. And then what we'll do is we'll come to 160 right at the end, and we'll just pull this up. Maybe to somewhere like here. Okay. And now what's going to happen is, you can see now it's spiraling, but it's gradually going up. So if we replay that, it's still going to look like a suspicious fluid, but as we pull it up, you can see now we'll be able to get that height that we need. Okay, and the reason why it's not kind of maintaining its shape is because the viscosity is not high enough. So what we can do is we can come and select our domain. Okay, go back to the physics tab, come down to where our high viscosity solver is, and I found that a value of 1 tends to work pretty well for this, but you might need to tweak it on your end. So if I go ahead and play this now, you can see it falls a little slowly, so you might need to tweak the time scale here. But you can see now it's holding the shape much better. Okay, if I leave that to play for a little bit longer, okay. We're getting our spiral there, right? It does kind of look like something you'd have to clean up after you took your dog for a walk, but don't worry, the shape will come in a little bit. Okay, so currently the simulation actually isn't going for as long as we need. Because it's high viscosity, it's going to take a little longer to settle, so I'm going to set the endpoint to something like 400. Okay, just in the domain down here. Okay, so what we can also do to improve this animation a little bit is, right now, the way it's coming out is the nozzle's actually kind of in the wrong place. You know, if you imagine, yes, this would be the shape of the cream as it comes out, but the nozzle actually is going to be rotated, right? It's not going to be, you won't be pointing it straight down. That would be a bit weird, and it also will affect how the flow comes out. It will kind of be rotated back this way, right? And it'll be coming out at an angle, if that makes sense. So we'll go ahead and animate that too. What I like to do is just let it play, just so we can see the shape of the way it's coming out, and then that will inform how we need to rotate it. So I'll play it just to the end of the simulation, up to frame 160. Okay, then we'll go back to frame 1. Being careful not going back to frame 0, because then it will reset the whole thing. Okay, and I'm just going to add some rotation in here. So we'll rotate it down in here. Because we've got auto keyframe on, it will go in the direction that we need it to. Okay, then as we come out to frame 20, you can see, yes, it's kind of getting the rotation we want now, but it's going in the wrong direction. So we're just going to rotate that in Z. Okay, so that the bottom of our shape here is kind of trailing in the direction of our fluid. Okay, and then we're just going to go through each keyframe. Oh, we're going to have to play it back again by the looks of it. We're just going to go through each keyframe, okay, and then make sure it aligns. So we have this nice fluid motion afterwards. Okay, so if we come to frame 40, we'll then rotate that around Z again. Okay, then the same again on frame 60. This will also help with the shape a lot. Right now we have pretty low levels of detail in our fluid, and that's why we're not getting the kind of shape that we want from our whipped cream. I just realized I put that on frame 61, so we'll just go ahead and redo that. By default, the divisions will be set to 32. We're going to increase it to 64, and now the how quickly it will take to simulate that will depend on your computer and the hardware that you have, but it will add more detail. Okay, nearly getting to the end here, frame 120. And then last but not least, frame 160. We'll bring that around again. Okay, so if I go ahead and play this now from scratch, you can see now it's going to rotate around as it goes. Okay, so it's almost like it's following the flow too. Okay, obviously it's not, it's coming out from our object. Okay, but that's just going to make this a hell of a lot cleaner. Okay, one other thing we could do is just to get a bit more of a peak on this, we could select our inflow. Okay, then we'll just add one last little bit, taking this up to 180. We'll just lift this up again, up to somewhere like this. Okay, then we'll also rotate it so it comes down straight. This will give us that nice kind of tip flick on the top. Okay, and we'll just rotate that back up to neutral. And then what this should then allow us to do is have a bit more of our flick up at the top. Okay. One other thing I'm going to do as well is I'm going to set the scale here on frame 1. So when it starts, it's a bit smaller, and then it kind of tapers out to be bigger as it goes, and then at the end we'll scale it in 2, so it sort of tapers off. So we'll just come back over to our transforms. Okay, we'll scale that in a little. Down to something like 0.5 probably. Okay. And then by frame 20, by frame 40, let's say, let's have that scale back up to 1. Okay, so now you can see that's scaling over the course of those 40 frames. And then at frame, let's say 140, we'll have that at 1 as well. Okay, so we'll just right click the scale and go to insert keyframe, and then we'll come to frame 180. Okay, and then we'll set that back to 0.5 as well. So if we go ahead and play this, what we'll now see is that it's kind of spiraling up, it's following the trail. Okay. And also it's going to taper in and out. So let's go ahead and play. So you can see it starts out small, gets bigger. Looks like we might need to tweak our rotation a little bit more. Comes up, and then tapers off, and we get that nice kind of flick. So what we need to tweak now is a bit of the rotation and also the shape. Okay, because right now it's still looking a bit weird. So we'll come back here. Okay. We'll come to frame 40, and it looks like we just need to tweak some of the rotation a little bit more, because it is following in the correct direction, but it's not coming out quite in the way that I would like. So we'll add a little bit more rotation in X. Okay, just so it follows that shape a little more. Okay, this stage can be a little tedious, but it's important, I think, to get the right shape for the flow. So So we're just double checking. Yeah, frame 100 looks like it could use some tweaking as well. Okay, 120. Just a bit. Okay. So what I'm going to do next is I'm going to come over to our domain. We're going to go back to physics, and I'm going to set the resolution divisions up to 64. A quick way to do that, instead of just typing it in, is you can do Shift 8 or Star on the keyboard, and then 2 to times it by 2, and then I'll set that to 64. So if I go ahead and play this now, it's going to be quite a lot slower, but it will conform much more to the shape of our nozzle. Okay, so as you can see, the shape is a lot better now. It looks much more like it's come out of kind of like a whipped cream nozzle. There's a few things I think we can adjust, but if I go ahead and play this back, you can see it's really coming out in quite a nice shape, and it's settling, and then we get this nice flick at the top. Okay, I think one thing that we can change is actually reduce the size even more at frame 180. So we'll come back over to the object panel, and then maybe we'll set the scale down to like 0.25 or something, just to really make that flick kind of like finer point to it. And you can have it, as fine or as like big and chunky as you like. It's really kind of up to you. But the scale of your emitter here will determine how big the simulation is. Okay, so now that that's gone like that, so I think when you actually come to render this, I like the divisions to be a fair bit higher than this. Maybe up to something like 124. It will really depend. We're actually going to go ahead and cache this out now. And you can go ahead and tweak these settings more if you like to make it thicker. We could also adjust the simulation speed. If we select our domain, we could set the timescale to 2, and that will make it come out much faster. But yeah, so that is essentially how you create a whipped cream animation. A lot of it really is just turning on the high viscosity solver and the shape of your emitter that really defines like how well this can work. And it took me a little while to figure out. But once you have those two things down, it's not too bad at all. There's one other thing that we can do, which is we can actually keyframe turning on and off the flow. And that will mean, because if we kept running this up to frame 500, it would continuously keep extruding, and it would just make a horrible lump. So what we'll do is use flow. We'll actually come to frame 1, and we'll keyframe that by clicking this little circle over here, and you can see it's turned into a diamond shape. That means it's keyframed. Then we'll come over to frame 180. Okay, and then we'll turn that off. So what will happen is it will animate the whole way, and then by the time it gets to frame 180, right at the top of our peak, it will turn off. Okay, if I go back and play that through again, okay, so you can now see that the simulation stopped and the rest of the fluid that we emitted is just kind of settling, and our object is staying still up there. So now that that's done, we've got a nice peak going on here. I'm quite happy with the shape. We can go ahead and actually bake this, cache it, sorry, and then we could even export that as an alembic if we wanted to use that in some other software, like I've done. So we're going to come back to frame 1. We're going to come to our domain. We're going to scroll down till we get to the cache section down here, and we're just going to select our start and end times, okay? So I'm going to have this run for about 400 frames, give or take, just to give it some space to settle. In fact, actually, well, ends around 180. Let's give it till like 250, because we don't want this to be too long. The files can get quite large. It could be anywhere from a couple hundred megabytes to terabytes, even in the really large scales. This will probably be a couple gigabytes. So we're going to set the type from replay to all, okay? we're then going to go ahead, and because this will be our final bake, or final cache, I'm going to increase the divisions here up to another ×2, up to 128. Now this will increase the file size, and it will take a while depending on your hardware capabilities in your computer. But once we have those two things set, you could also do this at 64 if you want to. Depends really on your uses. I'm going to go with 128. Once this is all set, we can come down and then we can change where we'd like this to be output to. I have a specific folder I want to do this into. So I'll paste that into the location up here. We'll go to accept. Okay, and then I'll just click bake all, and that will take a while, and then we'll come back when that's done. Okay, so our simulation is just finished. We can actually play this back now, and we can see it at a much higher frame rate. You can see now that we've rendered it much higher divisions of 128. We're getting a lot more detail actually in the whipped cream itself. So you can see we're getting all these nice, like, kind of tight curves, and the point just looks a hell of a lot better as well. Okay, so that's what the completed mesh looks like. The file it's saved out will be located wherever you decided to pick. This one here, and you can see the file is 5.3 gigabytes. It took a fair while to create, maybe about half an hour. But the extra detail is much more worth it, I think. And then, yeah, we can just view that in our viewport quickly. And then also what we could do as well is we could select this mesh, and then we could go and export this. We go up to File, Export, and then when you export it, you want to make sure you pick this as an ABC, an Alembic file, and then you could import this into any other software like Maya or whatever else you'd like to use, or just keep it in Blender as well as a separate ABC file if you want to actually get rid of the simulation. And yeah, that is how you can simulate kind of like a whipped cream, soft serve ice cream sort of look in Blender in a very, very short amount of time, and I hope you enjoyed it. Any questions, do let us know in the comments, and don't forget to like and subscribe for more videos. Thank you very much for watching.